Welcome to the course of Wireless Sensor Networks. I'm your instructor Zeeshan Bangash, and this is lecture number 21. Today we will be discussing the second part of the topic we have started in lecture number 20, that is related to the challenges, some security challenges in wireless sensor networks. So let's move to the outlines of our agenda. So today, as we have already suggested some security services in our previous lecture, so we will be talking about the secure group management. Then we will be discussing some intrusion detection mechanisms for wireless sensor network. We will discuss another security service, that is how to aggregate the data in a secure way. Then the denial of service attack in wireless sensor network will be discussed. We will understand why security is needed for a wireless sensor network. Then some DOS threats and the capabilities of adversaries. We will also talk about some physical layer attacks and some attacks on the data link and the network layer. We will talk about some attacks like traffic analysis, misdirection, the black hole attack, the transport layer denial of service attack. So this is the agenda items for our today's discussion. So let's discuss the first agenda item, that is secure group management. Now, the protocols for group management are required for two purposes: securely admit new group members, and it support secure group communication. Now, the outcome of group computation must first be authenticated in order to ensure it from a valid group. Now, any solution must also be effective and efficient in terms of time and energy. Now, the second important security service is the intrusion detection mechanism, particularly in terms of wireless sensor network. So we discussed in our previous lecture about intrusion detection and about some of its challenges and some of the advancements that needs to be incorporated if you are considering it for wireless sensor networks. Now, in a wired network, traffic or the data and the computations are normally monitored, and they are also analyzed in order to observe any anomalies at various points at various intervals. However, in terms of wireless sensor network, it's very expensive because they're very limited memory and very limited energy. So it is expensive in terms of network's memory and energy consumption. It also hurts the bandwidth, and it's again a main constraint. So wireless sensor network, as already discussed, needs a solution that is, first of all, performs the anomaly detection in a distributed way, and secondly, it should be inexpensive in terms of the resources. It should have a low communication overhead. It should be consuming less energy, and it should be utilizing less memory. So in order to look for anomalies, applications and threat models must first of all be understood. Now, it is very much important for researchers and practitioners to understand how cooperating adversary might attack the system. So for that, the different attack models needs to be understand and needs to be learned, so that if you're going to design a secure system or security service, So that behavior needs to be analyzed or observed in your proposed model, so that the such type of attacks or some combination of these attacks may be avoided. Now, the use of secure groups may be a promising approach for decentralized intrusion detection. So, this is the bottom line. Now, about the data aggregation, which is very important, we need secure data aggregation, and one of the benefit in wireless sensor net is the fine-grained sensing that a large and dense sets of nodes can provide. So this is the advantage. Now, the sense valued in WSNs must be aggregated, and that needs to be to avoid overwhelming amount of traffic back to the base station. So that will reduce the bandwidth uh, constraint, and also in terms of the memory utilization. Now, that upon the depend upon the design of the architecture of the network, aggregation may be performed at different points. It may perform at a cluster head level, or it may perform at a node level, or some part at the node level, or it may perform at the base station level. So all aggregation locations where aggregation need to be performed must be secured. So if the application tolerates approximate answers, so the powerful techniques are already available. So random sampling a small fraction of nodes and then checking that they have behaved properly supports detection of many different type of attacks. So this is the bottom line in when we are talking about secure data aggregation, that you need to perform random sampling on a small fraction of nodes, and then check that whether they're providing correct or precise data. Now, let's discuss some denial of services attacks in sensor network that create a bottleneck for this type of network. So, why security? Because in battlefield, in disasters, protect the location and status of the casualties from unauthorized disclosure, particularly if the disaster relates to ongoing terrorist activities. So, you need security. Similarly, for public safety, you do not need false alarms about chemical, biological, or environmental threats could be that will result in panic and disregard for warning system. An attack on the system availability could precede a real attack on the protection on the protected resources. Now, in also in terms of health care, uh, protecting privacy is a paramount. Only authorized user can query or monitor the network. Like, for example, if a patient wants to keep its data private, so only the doctor and the concerned consultant can just check the data and monitor that data. So that data needs not to be accessible to other. So these networks can also form critical piece of an accident notification chain, and thus must be protected from failure. So, denial of service threats. Now, a DOS attack is any event. DOS stands for denial of service. So, a denial of service attack is any event that diminishes or eliminates network capacity to perform its acceptance function. So, whoever wants to connect or try to send something on the network or wants to communicate with any central point, so he is given, or so that node is given the status of wait. So in this way the services of the network is denied. Now, hardware failure, software bugs, resource exhaustion, environmental conditions and their combinations, these are all sort of denial of service threats. So there are also international attacks as well, that's launched from different places and at different locations. Now, the adversary capability, the attacker can physically damage or manipulate node. uh, it may be less powerful than the normal functional node. It can add or subvert some nodes. It can interact with network only through software without physically providing a node, and that software through which it is interacting, it is as powerful as other nodes. It can immensely more powerful adversely that exist, and then existing wired networks with virtual unlimited computation and energy resource possible. Now, about a physical layer, that's basically the hardware where your hardware lies, and that directly interact with the medium. So there are some attacks like the jamming attacks. uh, for example, some defenses exist to overcome that. So like the use of spectrum, and using the regional mapping that we have already discussed in the data communication concept. It is also less expensive and very feasible for wireless sensor networks. Similarly, other attack on the physical layer are like example tampering. No, now the defense mechanism is that you need to hide the information, or some tampering proofing mechanisms needs to be incorporated. Then the second layer attack on the wireless sensor network, which is the link layer attack. So on the link layer, collision act take place. So a proper use of error correcting codes needs to be incorporated in your design model, in your software design model or your network model, so that the collision can be avoided. Similarly, exhaustion attacks occur, so that can be addressed using limiting the rates. Similarly, the unfairness mechanisms can be possible, so that can be avoided using small frames. Now, about network and routing protocols. For example, the neglect and greed we already discussed in the uh, previous lectures, that this neglect and greed mechanism provides redundancy, and that is very costly in terms of wireless sensor network. uh, Traffic analysis needs to be performed, and for that encryption mechanism, whether it is enough, but for wireless sensor network, the use of encryption mechanism will create an extra overhead because of the limited resource constraint. So it may be used, it may not be used, that depends upon the scenario. Similarly, some of the routing attacks like misdirection, for that aggressive filtering, authorization and monitoring mechanisms needs to be incorporated. So whatever mechanisms you have to add in a wireless sensor network, that will add another layer, and that may be very expensive in terms of computation, or the bandwidth or the memory utilization. So that needs to be evaluated first, because you want the network to be up for a couple of years, not for a couple of days. So, and redeployment always is costly. So these considerations have to be kept in mind before designing or proposing any solution for wireless sensor network applications. Similarly, the network layer, another attack is the black holes attacks, and that can also be avoided using proper authorization and monitoring and probing. So we already discussed in our previous lectures that for wireless sensor network, to avoid such attack, it is very much important that some intelligent and algorithm needs to be incorporated, that must perform the computation in a very optimized way, so that the resource constraint issues may be avoided. Now, the neglect and greed, what is this concept is that the neglect process drops packet arbitrarily, and greed gives undue priority to its own messages. So this is the mechanism, some of the one of the challenge. So how to avoid it? Use multipaths and use a redundant message to mitigate these effects. So that can help to avoid this neglect and greed attacks. Now, about the traffic analysis. Geographic forwarding allows attacker to figure out where important nodes are. Now, there are some of the attacks in which the node uh, tries to portray itself to be present in a location where it is not physically available, and it try to replay all the traffic of that area routed through its current location. It's basically a flow control attack. So that can be avoided using geographical forwarding. We will discuss a sort of that attack in the upcoming slides, like the cyber attack and the black hole attack. So geographical forwarding, so adding geographical information with the packet, and then analyzing it at a particular place, so that to identify that whether the origin location of the packet is actually that location which the sender claims, or it is an anomalous location. So geographical informations within the packets needs to be incorporated. Similarly, encryption header as well as contents might elevate this issue. Cryptographic means that may not help with the communication better in is many to one. Just watch traffic intensely. So misdirection is diverting the traffic from intending destination, targets the sender. So this is a sort of the attack which we have discussed, just to disturb the flow of the traffic, and portraying the false routing information or false location information within the network. So it basically targets the sender. Now the misdirecting packets may flow in one directions, and it may targets the receiver, or the victim may be the receiver. Now what is to how to prevent misdirection is basically the aggressive filtering, and that aggressive filtering needs to be performed at some cluster heads or at some locations, at some positions, some points in overall network, so that the misdirections can be avoided at multiple places. Now, how to do that? It needs verification of the source address, and it verify whether the information is legitimately generated from that particularly source. An example of another attack we have talked about in our previous slides is the black holes. Now, the distant vector based routing protocol has a weakness, and node can advertise zero cost routes to every other node, and that can attract uh, traffic towards itself, because it's a very less costly route, since the node have advertised it as a most effective way of reaching the destination. So this is the weakness in distance vector based routing. Now how to fix it? A proper authorization and monitoring mechanism, like the watchdog mechanisms, through the coordination with the neighbors, that needs to be incorporated in order to avoid these black hole attacks. And similarly, the probing mechanisms like sending periodic messages across topology to test for blackout regions, or the black and gray regions in the networks, to and then uh, further communicate this information to other nodes. Similarly, that can be helped to provide to redundantly place the information about routing at multiple places, so black holes can be further be avoided, in order to check the actual location or the route information or the route priority or the route cost, to verify it from multiple places. Then there is another layer attack which is known as the transport layer DOS attack. That's basically the flooding. What happens that the adversary commit resources. It all the resources are tried to the attacker try to allocate the resources to itself. Now it's only useful if adversary has limited resources. Now desynchronization and needs to be incorporated in order to discourage that type of attacks, and it can be processed through authentication. So in our today's discussion, we continued the topic of security services in wireless sensor network, and then we talked about some of the attacks and its parent, like and its pattern, like denial of service attacks. Similarly, we talked about the some of the physical attacks that are part of the hardware, and how to avoid these attacks. Similarly, we talked about some link layer attack that can be incorporated through effectively avoiding collisions by incorporating a good error detection and recovery techniques. Then we talked about some network layers, those attacks that can that can affect the routing information, and how to avoid it. And so some extra information that needs to be kept, and the data and the root information needs to be placed at multiple places, that can help to avoid the network layer attacks. Then the transport layer attacks, and how to avoid it by introducing proper authentication mechanisms. So with this comes the end of our today's discussion. So this is the reference book from which the content has been taken, so you can just consult it. And thank you very much for patiently listening. Take care. Allah Hafiz.